Hello viewers, welcome back. This is MIJ Tech Hacks, this is MIJ Technologies, and today we are going to cover another part in module 3, control flow. Remember, we are covering control flow and we are into our load to the complete Python course. Remember guys that we shall always find our notes that we follow along all the course notes on our platform. You go to our YouTube channel, then in our YouTube channel, then you go to the search bar and type MIJ Tech Hacks. When you type MIJ Tech Hacks, they will bring for you this. Then when you tap into the logo, it will take you directly to where our videos and everything are, our tutorials. So at MIJ Tech Hacks, we have on our official page of YouTube, we have where they are about what is about the channel. Then there is this option where there is more. It is where we go, then we click to there are links that there is my GitHub portfolio link, there is my LinkedIn link, there is document files for courses. Then on document files for courses, you double click and then it will take you directly to where our course notes that we use throughout this course. So we have this Python cheats. I always upload the Python cheat codes, and so that you pass through how to summarize and simplify some things in Python. So here are some sheets that you can use as far as Python is concerned. Then we also have our Python full course, that is from beginner to professional Pythonista, and within it we have module 2 that we already covered. Then we also have module 3 that we are untangling at this very moment. So when you double click module 3, it will give you options like download. This is a 33-page document. So this is the document that we are using to follow along during these tutorials. When we reach to module 4, I'll also upload module 4 notes that we shall be following throughout the videos, also throughout the lecture tutorials. So that is it, and that is MIJ Tech Hacks. That's where our module notes are located. So with that brief preamble, allow me introduce to you what we are going to go through today, and that is we are still untangling module 3. And last time we appreciated very many things, and today we are going to also appreciate something new. So welcome back. Last time we properly separated the break and continue statements. Last time we properly separated the break and continue statements. Leave the building versus skip one item. Remember, break leaves and the other one just skips. So today in part 7, we are closing out our loop control toolkit with pass, and then we will be picking up something called the loop else, which is honestly one of the Python's best kept secrets for such style code. After that, we will be combining everything we've learned so far: loops inside loops, decisions inside loops, into real layered logic. So let's get into it, and I want everyone to open their document or to open their notes, because these same notes I'm going to close them, but they will be the ones that I'll be using to elucidate or to explain concepts throughout this tutorial. So I request that you have another screen with this document opened, or you have a printout of this document. Whatever the case, you need to have the document open so that we follow along with the coding examples, we follow along with everything throughout the document, so that we can be on the same stage. So that is it, and I want us to dive into today's session, which is probably we are going to cover the loop control toolkit with pass. So that is it. Let's open our VS Code. So let's first of all go to today's topic, which is pass. Continue. We covered everything about continue. So that is it, and They say that pass is a placeholder. It tells you do nothing. Pass does absolutely nothing. It is used as a placeholder when Python requires a statement but you have not written the logic yet. So Python does nothing, and it is used as a placeholder when Python requires a statement but you have not written the logic yet. So that is a brief preamble about what pass is, and that's what we are going to cover into this session. So here is a very situation you run into constantly, where once you start building bigger programs, you are sketching out the shape of your code before you've actually written the logic yet. But Python has a strict rule. After a colon, like after an if or after a for, there has to be something indented underneath it. An empty block is a syntax error. So Python won't let you leave a decision or loop completely blank. That's exactly what pass solves. It is a statement that does absolutely, genuinely nothing. It's purely a placeholder that satisfies Python. Python is you must have something here rule, while you figure out the real logic. So that's what pass does here. So let's try to open our VS Code and we see. Let's try to open our VS Code. Let's try to open our VS Code and we see what is going to be taking place. Let's try to open our VS Code. So for example, let me first get rid of this. Let it first load. Let's get rid of this. So for example, if we have for I, so we have said that the real situation that you might run into constantly once you start building bigger programs, you are sketching out a shape of your code before you've actually written the logic yet. But Python has a strict rule. After a colon, after an if statement or after a for statement, there has to be something indented underneath it. An empty block is a syntax error, so Python won't let you leave a decision or a loop completely blank. So that's exactly what pass solves, and we are going to go through it in this example to appreciate how it comes along. So let me first of all increase the font so that viewers can see very well. So we have something like for I in range 5. Remember, now you understand these statements. When I say range 5, it means that we are going to start counting from 0 and end on a number that is 1 less than the number that is specified in the argument of range. So that is it. So for I in range 5, pass. For I in range 5, pass. So when you see such a statement, for I in range 5, pass, you could sometime in your program use this statement that for I in range 5, pass. So this loop runs 5 times and does literally nothing 5 times. Looks pointless on its own, but watch how useful it is while you are actively building something. So that is it, and this thing will always do nothing. Even if you try to print, nothing will print, but internally this loop will run 5 times and it does nothing, just to run 5 times. It looks pointless on its own, but in the later time you will appreciate it while you are actively building something. So we have an example here. Let's first of all go through this example. Let's get rid of this. So we have a sample example in our notes. Score is equal to 45. Score is equal to 45. We have our variable score equaling to 45, and then we have an if condition. If score is greater than or equal to if score is greater than or equal to 50, then what are we going to do? We are going to say pass. Else print you did not pass. So if the score is greater than or equal to 50, we shall say pass, else print you did not pass. So we shall have a print statement saying you did not pass. You did not pass. You did not pass. So that is it. Now let's try to see what comes here. So let's try to put let's try to see what comes here. You did not pass, because score is we have such a condition that if score is greater than or equal to 50, but our score here, which we have initially, which is in our variable, is 45, and 45 is not greater than or equal to 50, so it is less than 50. Hence this statement becomes false. So this pass statement will not run, the else block will always run. That's why it has printed you did not pass. So if the statement was true, nothing would have taken place. Like as we see, if we change our score to be 55, let's see what gets printed. Nothing, because it just passes that, and the else part is skipped. So that's what it does, and you will notice its use when you start building big programs. You might not have interest in it at this very moment, but what you need to know is why it is existing, and what you need to know is it is existing. So that is it. So here I know eventually, here I know I eventually need to handle the passing case, but I haven't written that logic yet. Maybe I'm still deciding what should happen. Pass lets me leave that block empty, syntactically valid, and come back for it later without breaking my program. So when I say pass, I think I might have put in conditions underneath this if block, but I first of all wait and then carry out my program. If the condition is true, there might be some other statements that I might put, or I could put print this, or I could put another if statement which is nested inside this if statement. But I'm not yet ready to put these statements. So the first thing to do is, I know I will use this structure, or I will use such and such syntax into my program. I will need it at some point, but I'm not sure of what I will be putting inside this indented block of if. So I first of all put pass to first of all act as a placeholder, which at another time or later in our code I could come and then put anything that I want. So that's what pass really plays, and that's the good role of pass, to act as a placeholder in our blocks of code. So if I eventually need something to handle the passing case, but I haven't written the logic yet, maybe I'm still deciding what should happen, pass lets me leave that block empty, syntactically valid, and come back to it later without breaking my program in the meantime. Think of it as a sticky note that says come back to this rather than actual functionality. So that is it, and I hope someone has appreciated the use of pass. So now here is something most beginner course skip entirely, but I think it is honest one of the Python's neatest tricks you already know. That is the if else one runs, the other doesn't. So you already know that the if else one runs, the other doesn't. But did you know that a loop can have an else too, and it has a very specific, very useful meaning? The else block after a loop runs only if the loop finishes. So that is it, without ever hitting the break. Let's first of all understand this. So guys, I have told you that you already know that if else one runs, the other doesn't. But did you know that a loop can have an else too? And it has a very specific, very useful meaning. The else block after a loop runs only if the loop finished completely on its own without ever hitting a break. For example, if we have names as our list, let's say Alice as our contents in the list. Then we also have Bob, and then we also have Bob. That's right. If you have Alice, then we have Bob, then we also have David, and we also have Eve. Lastly, we have Eve. Then we have our target that we want color. The target is that we need color. Target is we need color from this list. Need color. Color must be in quotes, remember. So the target is we need color. So we put our loop that says for name in names. What are we going to do? If name, we have an if condition inside the loop. If name is equal to target, which we already said, if name is equal to target, what should we do? Print the target which is found. Print our f strings target found, or you could say color found, because color is now the target. Target found. Then we shall have the break. Then in the else part, we shall have it as print. If the target is not found, then we shall print this statement, f string target was not found in the list. So that is it. That is what we have. So this is a search. We are looking for color inside our list. We check Alice, not match, because Alice is the first item in the list. We check is Alice equal to our target, which is color. It is not a match. So what does it do? It comes here in the loop. For name in names, if the name is equal to target, then we shall print target found. If it is not found, the target was not found in the list. So that is it. It first of all checks this, then it breaks. With breaks, this loop is completely broken. It goes back to check the second one. It goes back. So that is it. Let's try to see. We check Alice, no match. Then we check Bob, because Bob is the next, no match. Then David, because Bob is David, because Bob is the third one, again it is no match. Then we also check Eve, which is no match. We reach at the end of the list. So after checking that we have no color inside, after checking that, after appreciating that we have no color inside, it will first of all run the whole list before it goes through this break statement. After it has gotten into the break statement, it will break only this break breaks the loop and goes exactly to what is down there. So it breaks this because it has not found anything. Then it prints this loop that the target was not found. So that is it. So we never hit that break statement because we never found what we are looking for. So you see that there is for name in names. If the name is equal to target, print the target was found, then break. So because we never get what the target is, we shall never hit this break statement, because break statement kills the whole loop, and then everything underneath is not going to get ran or evaluated. So we never hit this break statement because these statements are never true, and this break statement is inside this if statement only after and after if the name is equal to target. So we never hit this because the name has never been equal to target. So the else block will only run, because after running this statement that the name is, if the name is equal to target and this statement becomes false, this will be skipped, everything underneath the loop will be skipped, and we shall go to the else block, which will print target was not found in the list. So that is it. You appreciate that we never hit the break statement because we never found what we were looking for. Because the loop finished naturally, ran clean through every single item without ever breaking out early. That else block fires and we get color was not found in the list. Now flip it. Imagine color was in the list. Let's try to flip it. Imagine color was in the list. The moment we found her, we would hit the break, then print color found, and leave the loop early. And because we broke out, that else gets completely skipped, as if it wasn't even there. That's the entire rule in one sentence. The loop's else only runs if break never fired. Why does this actually matter in real code? Because it perfectly captures the idea of I searched the whole thing and genuinely did not find it, versus I stopped array because I found it, without you needing a separate flag variable to track which situation you are in. It is a small thing, but once it clicks, you will start spotting places where it genuinely simplifies your code. So that is it, and you need to take keen note of this. We have names Alice, Bob, David, and Eve, and we want to look for whether color exists. So we have a loop that says for name in names, if the name is equal to target, then this loop inside it will print and then break the whole loop. But what if this is not true? The else part will run and says we searched the whole of the list and we did not find anything like color. So that is it, and this thing is always skipped when they are teaching, but it is once also giving a keen eye. So we are going to go further, and I think we looked at pass, and we have looked at this uncommon pattern in Python. So we are going to look at nested loop, a loop living inside another loop. According to our notes, nested loops, I think our next part. Let's try to go and check into our notes. So we have seen the else clause on loops. Python allows the else block. Python allows an else block after a loop. It runs only if the loop completed without hitting a break. Very useful for such operations. So that is what we have been explaining. So the else only runs if the loop finished without hitting break, because if there is nothing that is fulfilled, of course break won't run because it is under the indentation of the if block. So output color was not found in the list, and that's what we have been discussing. That's why I told you guys it is always better for you to open your notes during these discussions so that you can always follow along. So now we are going to cover the nested loops and conditionals. Nesting means we are going to untangle the nested loops and conditionals. Nested loops and conditionals. Nesting means placing one loop or conditional inside another. The inner block runs completely for each single iteration of the outer block. Use nesting carefully. Deeply nested code becomes hard to read. So putting a loop or a conditional inside one another is what we refer to as nesting. And let's go to untackle it. So nested loops, we shall see, for example, the multiplication table. So let's try to go and let's try to untangle this. So when we continue, when we combine loops with loops, nesting means placing one loop entirely inside the body of another. So here is the mental model I want you to hold on to. The inner loop runs its full course completely, start to finish, for every single pass of the outer loop. For example, if you have something like this, let's try to get rid of this. For example, if you have something like this, for row in range 1 4, the start point is 4 and we stop before the starting point is 1 and then we stop before 4, exactly 1 less than 4. So we shall have it as for row in range, we shall say for column in range 1 to 4, in range 1 to 4. So we see that the first loop, it says that for row in range, so you know that multiplication tables run row by column. So for row in range 1 to 4, then for column in range 1 to 4, what are you going to do? Product is equal to row by column, which is how multiplication tables work. So row by column, which we called column. Then we shall print using our f string. We shall print the product. Then we pad it with the array here. You will know why that exists. You are going to know why that exists, and you are going to first of all get rid of it and know why it's used. So end equal to blank space, then we shall print a space after the loop to separate or to for easier formatting, to skip one line, to print a blank space one line before another row is generated. So let's try to see here what gets printed. So when you try to run, we see that there is spacing, and that is what takes place. So it says 1 2 3, then 2 4 6, then 3 6 9. So that is what gets printed, and I hope someone appreciates. So when you try to trace this profile, when we try to trace this properly, because watching it unfold is the whole lesson. Outer loop starts, row is 1, outer loop starts, because it will start with row 1. This is the outer loop, which is for row in range 1 to 4. It starts, row is 1. Now the inner loop runs completely from start to finish. When the row is 1, this inner loop is going to run with the row equaling to 1, then row equaling to 2, then row equaling to 3. And then afterwards, when row is equal to 4, this inner loop will also run for 4 value, which is when column is equal to 1, and when column is equal to 2, and when column is equal to 3. So it runs completely for each value that is in the first loop. So if if we are now at the first value, or if we are now at 1, it will print all values that for this value, which is 1. So it will run completely for each value in the first loop. That's why we say when outer loop starts at at 1, the inner loop runs completely from start to finish. Column gets 1, 2, 3, calculating 1 times 1, 1 times 2, and 1 times 3, because it is now at value 1, printing each one on the same line because of that end trick. So that end is that this statement that we have here, makes us enables us to print each one on the same line. Because of this, it forces every result that is printed to be on the same line. That's why we have something like the result is 1. After multiplying 1 multiplied by 1, the result is 1. 1 multiplied by 2, the result is 2, and 1 multiplied by 3, the result is 3. So it goes to now this one goes to the next one, which is 2. So it multiplies 2 multiplied by 1, it becomes 2. Then it multiplies 2 multiplied by 2, it becomes 4. Then 2 multiplied by 3, it becomes 6. Then it goes that one is done. Then this one goes to 3. 3 multiplied by 1, it becomes 3. Then 3 multiplied by 2, it becomes 6, and this one becomes 3 multiplied by 3, it becomes 9. So the range is complete, and now everything gets printed like that. So that is it, that end trick, which stops print from automatically jumping to a new line once the inner loop is totally finished. We hit that lone print outside the inner loop, but inside the outer one, that's what pushes us to generate a new line. So that is it, and I hope you appreciate what gets printed. So when you notice the pattern, for every one pass of the outer loop, the inner loop ran 3 complete times. That's nesting, and that is nesting in a nutshell. So we are going to look at nested loops for shapes, the star pattern. Let's go and look at nested loops for shapes. What do we have next into our notes? When we try to open our notes, so we have seen the multiplication table, how it is generated. So let's look at the nested loops, that is the star pattern. Let's look at the nested loops, and that's the star pattern. So when we have something like our variables, loss is equal to 5, loss is equal to 5. So shall say that for I in range 1, then space rows plus 1, rows plus 1, rows plus 1, then inside it we shall have for j, because we are dealing with nested loops, a loop inside another loop. So for j in range I, we shall print the star. Shall print the star. Shall print the star. Then, because we want them to be on the same line, shall say so. After the loop, we shall print a space. So that's our loop. Let's try to see what gets printed. You see what gets printed. We see that the first thing, let's first of all untackle this. Rows is equal to 5. So we see that what gets printed is a right angled triangle. When we a right angled triangle, let's try to count the height. 1, 2, 3, 4, 5. So this rows gives us the height. These rows give us the height. This variable rows that we stored gives us the height. So we see that it is a right angled triangle with the height 5. Let's try to increase this to 10, and then we see. Let's try to increase this to 10, and then we see what gets printed. So that first variable gives us the height. That's why the triangle gets printed. Let's try to count. 1, 2, 3, 4, 5, 6, 7, 8. That's what gets printed. So that is a triangle built purely because the inner loop's size grows in step with outer loop's counter. So that is genuinely an important idea. The inner loop doesn't have to be a fixed size every time. It can respond to whatever the outer loop is currently doing. So let's try to run this of height 5, right angle triangle of height 5. So in range 5, let's try to see 1, 2, 3, 4, 5. That is it. So that is a triangle built purely because the inner loop's size grows in step with the outer loop's counter. That's genuinely an important idea. The inner loop doesn't have to be a fixed size every time. It can respond to whatever the outer loop is currently doing. So let's genuinely build this ourselves now. According to our module notes, this is exercise 11, nested loop star pattern. Open your PDF to that page. Let's try to go and track that exercise here. Let's try to go and track that exercise 11. According to our notes, it is exercise 11. Where is exercise 11? So that is it. It is the nested loop star pattern. And the task that we have, print a right angled triangle of stars with 6 rows. Print a right angled triangle of stars with 6 rows. So let's go and print it, and we see how it comes about. So we shall have something like rows is equal to 6. Let's just see. Let's go to our VS Code, and then we try to run this. The task is to print a right angled triangle of stars with 6 rows. Let's try to get rid of this. So we shall say rows is equal to 6. Rows is equal to 6. Then we say for I in range, in range 1, we shall say for j in range. I've not used the same variables because here I use I and in the next one I use j. So you try to change the variable, don't use the same variables when we are in nested loops. Shall say print, shall print this star and ensure they get printed on the same line with this. Then after the loop we shall print a blank space. So this is the exact same pattern we just walked through, just with the rows set to 6 instead of 5. Type it live, run it, and count the stars in each row as they print. So let's try to run it and then see what gets printed. So the first one, 1, 2, 3, 4, 5, 6. So this one gives us the rows. This one gives us the rows. This is why these are 1, 2, 3, 4, 5, 6 rows. So that is it. I want you to go through it, then run it, type it live, run it, and count the stars in each row as they print. 1, 2, 3, 4, 5, 6, and connect that count directly back to the current value of I in the outer loop. That connection, the inner loop's size, literally is the outer loop's current counter, is the entire concept that this exercise is testing. So that is it, and I hope someone appreciates. Putting a decision inside the loop. Let's try to go to what is next into our notes. Putting a decision inside a loop. Putting a decision inside a loop. Putting a decision inside. So if inside a loop, that is that is our section 8.3. So we've nested loop inside loop. Now let's nest a decision inside a loop, which honestly you will do constantly in real programs. So for example, if you have something like this, let's try to go through this example. These examples are in our module notes. That's why I always sometimes just copy and paste. So if you have a list of scores, which is 85, 42, 91, 67, up to 95, then we say for score in scores, if the score is 80, then we shall print the grade distinction. Then if the score is 60, we shall print the grade as credit. Then if the score is 50, then the grade will be pass, then else the grade will be false, and then print the statement. So what gets printed is after, if one of these blocks runs, we shall skip the other block and then print what has taken place. For example, let's try to see. For score in scores, we shall print the result for 85, the result for 42, the result for 91, and everything into this list. So we shall print it with this F string, which is a score, and the value is that, then its grade is that. So if it is 85, we expect it to be a distinction, and 42, we expect it to lie into this fail. So the first one will be distinction, then fail, then distinction, and then 67 will run into credit, like that. So let's try to see. So the first one will be the distinction, fail, distinction, credit, pass, credit, fail, distinction. So that is it, and I hope these patterns you appreciate them. So nothing new. Nothing new syntax wise here. This is literally our if, elif, else from part 1, just living inside a for loop, and it makes sure that everything runs and everything gets its value. But notice what that combination actually gives us. We are now classifying every score in the list one at a time automatically inside writing, automatically, instead of writing every separate if statements by hand. So that's the real power of combining loops with decisions. The loop provides repetition, the if elif provides just judgment, and together they process a whole collection intelligently. And now you can nest the other in the other direction to a while loop sitting inside a for loop, which is exactly the shape we used back in our input. So I think that is today's session. Before we practice before we practice practical warning: every extra level of nesting multiplies the total work your program does, not just adds to it. A loop of 1000 items nested inside another loop of 1000 items doesn't run 2000 times. It runs the inner body 1 million times, because for every single one of those 1000 outer passes, the inner loop runs its full 1000 again. So it's a genuinely practical guideline. It is a genuinely practical guideline. Try to keep your nesting to a maximum of 2 levels in most everyday code. If you find yourself needing a 3rd or 4th level, that's usually a strong sign. You should pull that inner logic out into its own function instead. So that is it, and that has been part 7. That's part 7 done today. We've covered pass as our I'll finish later placeholder, the loop, else as a genuinely elegant way to detect everything. We searched everything and found nothing, and then we combined loops with decisions. That is the multiplication grids, the star triangles, grade classification across a whole list, and validation nested inside a bigger collection loop, plus a real practical warning about keeping your nesting under control. So in part 8, we are doing a full recap and the common mistakes that we already found along when we are discussing this, working through the big combined exercise 12, a full meaning number analysis program, and then assigning the first 3 self-study exercises for you to attempt before our next session. So in the next video, MIJ Tech Hacks, MIJ Technologies, we meet in the next tutorial. Bye bye.